In this section of the course, we're going to talk about how geospatial data works. Specifically, we're going to focus on what's known as vector data. And even more specifically, we'll focus on simple features data, which is how vector data is represented in R. What you're looking at here is a slide from some materials made by Andrew Heiss, a professor at Georgia State University. He's talking about how SF, or simple features data, is the standard today. He's focusing at the top here on geom-SF, which is how, as you saw in the intro lesson, you can make maps in ggplot. And geom-SF relies on simple features data. Now, as Andrew points out, you're going to sometimes find older tutorials or things on Stack Overflow that talk about using things like geommap or ggmap, or maybe you'll even see something called like SP. All of these are older formats. SF data is the standard that everybody uses for vector data at this point, and it's definitely what you should be using. To show you how SF data works, let me load a couple packages. The most important here is the SF package. That's going to enable us to work with simple features data. I'll also load the tidyverse because I'm going to make a couple maps. Okay, next I am going to import some data. So you can see I am importing data on Wyoming. So you can see here on line 5 that I'm using the read_sf function. That will import a wide range of geospatial data. We'll talk in a future lesson about different data types, but just know that the read_sf function can basically read them all in. Okay, so I'm going to run that, and now I have an object called Wyoming. I'm going to run it there and take a look at it down below. You can see that it shows up as a simple feature collection with one feature and one field. Now, down at the bottom here, it just looks like a tibble, right? It even says tibble 1x2. But at the top, it's got a bunch of metadata. So let's start out with the geometry type. The geometry type for this data is polygon. Now, if you know Wyoming, this probably makes sense to you, right? Wyoming is a rectangle. In fact, I'll run ggplot and then geom-sf with data equals Wyoming, and you can see the result that we get there. It's a polygon. Let me import some other data. This is Wyoming 1 EV station. So I basically created a little data set that has just one electric vehicle charging station in the state of Wyoming. And when I run that, if we take a look down here, you can see geometry type equals point. Now I'm going to run this code on lines 17 through 19, and I'm going to put Wyoming there, and then I'm also going to add Wyoming 1 EV station. And you can see down below here how we have now one EV station. And that makes sense, right? It's a point. It's one little object that we put on a map. So we've covered data where the geometry type is polygon, and we've covered data where the geometry type is point. Let me show you one other, which is line string. So here I am importing data on Highway 30, which is a highway that runs through Wyoming. If I run that, go down here, you can see geometry type line string. So now I'm going to plot this with lines 26 through 28 and watch what we get. You can see a little bit of Highway 30 showing up in Wyoming. Everything we've seen so far is one instance of its geometry type. So we've seen a single polygon, a single point, a single line string. But you also have what are known as multi-variants of these. As you'll see, we're going to talk about multi-point, multi-polygon, multi-line string. Let me show you what these look like. Now, Wyoming's not a multi-polygon because it's just one big rectangle, but Rhode Island is. I'm going to import data on Rhode Island and take a look at it. You can see down here, geometry type equals multi-polygon. Let me show you a map of it to show you why it is a multi-polygon. So when I run this, you can see we get Rhode Island, and take a look at it. Confusingly, Rhode Island is not actually entirely an island, but as you can see, it does have several islands on it. And so to draw this, you couldn't just have one polygon, you need to have multiple polygons. I'm going to import data now on all electric vehicle stations in Wyoming. Take a look at that. You can see the geometry type there is multi-point. As you can imagine, there are multiple points, and if I map this, you can see there they are. Let me import data now on roads in Wyoming. So this is all roads throughout the state. And you can see that shows up as a multi-line string because there are multiple lines because there are multiple roads. Plot that, and there we go. Okay, so we've talked about the geometry type for SF data. Let's look at the next item that appears in that metadata at the top of our SF objects. I've run Wyoming again, so we can see that. It's geometry type polygon. Next is the dimension. It is XY. All that means is it's two-dimensional. There are ways that you can add other dimensions to SF data. That goes way beyond anything we're going to do. So all of the data you're going to see in this course will have dimension XY. Okay, the next item we can see is the bounding box. I am showing it here for Rhode Island, which again was a multi-polygon. The bounding box is basically if you draw a box around your SF data, where does that box show up? So the box has to kind of contain the entire data set. The code from line 60 to 65 creates this bounding box. Don't worry about that. What's more important is if I plot this. So I'm going to plot it and I'm going to show Rhode Island. And then in red, I'm going to add that bounding box. So you can see now we've got our map of Rhode Island, and then we've got that bounding box on the outside. We're not really going to use it very much, but it's important to know what it is. Next, let's talk about projections. Now, there's a lesson later on that will help you to choose good projections. For now, all you need to know is that projections are simply a way to try to represent what is inherently a 3D object, that is, the Earth, in two dimensions, that is, on a flat map. So if I take a look at Wyoming again, you can see I have geodetic CRS. CRS stands for Coordinate Reference System. Now what I'm going to do next is I'm going to create an object called Wyoming Different Projection. And you can see I've used on line 80 ST transform to give it that different projection. If I run that, you can see now my projected CRS is NAD 83 Canis Albers. Okay, you might be thinking, oh, okay, what does that mean? Well, let's take a look at them visually. Okay, so if I run Wyoming and make it into a map, you can see we get that. But if I take my Wyoming different projection, see how it's tilted a little bit. And basically in this second projection, it's trying to kind of show a little bit more like the curvature of the Earth. The last and kind of most important part of simple features data is the geometry column. In addition to all the metadata that lives at the top of SF objects, as you've seen, all SF objects also have a special geometry column. So if I run Wyoming here, you can see I've got this geometry column down here, and you can see that it basically has, in this case, like a bunch of points. So if you're wondering what's going on here, the easiest way to think about this is like those draw by number books that you may have done as a kid. So these books have like point number 1, point number 2, and your job is to connect them all. That's basically what the geometry column is doing. In this case for Wyoming, it's got, okay, there should be a point at negative 106.3212 and 40.99912. Those numbers represent the longitude and the latitude. And you can see then it continues. It's got then minus 106.3262 and 40.99927. And so if you were to make little points where each of these are and then connect them, that's how you end up with the outline of Wyoming. To show you this, I am going to create an object called Wyoming coordinates. Okay, so in lines 96 through 101, I've got code that just actually creates all of those coordinates as a tibble. So this is not SF data. And so you can see we've got longitude and latitude, and these are all the points. We've got 8,583 points that make up this polygon in Wyoming. Now I could actually take them and plot them using geom_point. And if I do that, you can see I've basically got the outline of Wyoming. An even cooler way to see this is with this animation that I've made, which shows the points being added to the map. And so you can see how one by one, adding these points to the map, and then actually it's not happening here, but you could draw a line between them, which is exactly what geom_SF does. That's how that geometry column gets used to make plots. Okay, for your turn, what I want you to do is I want you to run the following code in order to import an SF object called Africa. I've got the code here. I'll put it in the Your Turn section below. After you've imported it, I want you to examine your object, ensuring that you can identify its geometry type, dimensions, bounding box, coordinate reference system, and geometry column. And if you want to go further, go ahead and try making a static map with the geom_sf function from ggplot and or the map view function from the map view package.